to everybody. Welcome to SGI Dubai 2021, to this Extris presentation about screen printing technology. Today we will see how to choose the best material, the best grid for T-shirt screen printing. Let me speak about Extris, my company. I founded it in 2008, nearby the border between Italy and Switzerland, in the north of Italy. Maybe you heard about Lake of Como. We are there. That's the Italian textile district. And there we grew up in 2008, becoming rapidly the third European mesh weaver. That means there are only 3 manufacturers of screen printing mesh in Europe. And one of the 3 is Extris. And what distinguishes us is our quality management system that is certified to the ISO 9001. We have also an environmental management system that is certified to the ISO 14001. So we care about the ambience, we care about the environment. By the way, our factory is inside a natural park. Well, what is Extris? Extris is a textile weavers. So we do weave, we use loom, and among the loom we choose to have Dornier looms, Germany. That's German loom. It's very sophisticated, quite expensive. It's considered to be something similar to what Rolls-Royce is among the car. It's the queen of the cars. Well, Dornier is the king of the looms. It's the best loom, the most expensive, but very flexible, very precise in what you do. And that is what we need for our technical textile. Here is an example of the mesh we produce. You see, it's very regular, very regular. And the product range that we produce is named Suprex. Suprex stay for Superior Register Fabric from Extris. Later on, you will understand what means register for a screen printing mesh. This is one very important parameter that defines how well a fabric under tension can keep the original geometry, so the original opening, the main characteristic, and so how well that fabric will print. By the way, we are proud for that, the sole screen printing mesh manufacturer in the world to have achieved the OECO-TEX certification. That means our fabric, our mesh, have been tested by OECO-TEX, and OECO-TEX guarantee that are not hazardous for the human skin. That is the skin of an old boy like me, 60 years old, or the skin of a young child that may use a product printed with our mesh without any concern about it is hazardous or not. That's just a snapshot of the product range. It's quite full of numbers. And you see on the left, on the column on the left, we have a list of items that we distinguish one from the other by the number of thread per centimeter that we can put in that mesh and by the diameter of the thread we have been using for weaving it. Then you find in a spreadsheet like this one a bunch of numbers that are useful for designing, for, let's say, simulating what will be the result of your screen printing process. Really, screen printing is not just an art. It's a science, because you can predict the quality of the prints that you will make by using a specific item, a specific mesh, by this number. And this is something that we will see very rapidly today. Well, this is a nice chart where you compare the different printing job possible with screen printing to the most common mesh count. you see that we have divided into range of mesh counts on the right mesh, and we do suggest for any specific printed job the right range of mesh to be used. For example, poster and billboard printed with UV inks normally use mesh threads by 140 to 165 thread per centimeter. So a very fine mesh where the mesh opening is very small. While if you look into this list on the left and you go to glitter on T-shirt, you see that glitter on T-shirt that is very dense ink, it's particulate inks, then it's advised to use a mesh with 8 thread per centimeter up to 27. And this is a rule of thumb. See, this is just to address the printer in the fastest way to choose the right product range for the specific job. Few words on the dictionary, because later on we will speak about warp, weft, open area. What is that? Okay, the architecture of a mesh, so the way we produce it, characterize the mesh itself. We call it plane weave. This is the most typical structure of a mesh, plane weave. And we distinguish two directions. One is weft, the other is warp. And the yarn are put or in the warp direction or in the weft direction. And by crossing each other, they leave a hole that we call open area. And this hole in our mesh, in our business, it's fully squared. It's precisely square. Along the length of the mesh that we weave, you will always find the same size of hole and always the same geometry. So squared with the same size. And the number of threads, the number of yarn that we put in a centimeter, we call mesh count. And the thread diameter that we use is a single wire, is a single yarn, and has its own diameter, and we look to it as a thread diameter. As I mentioned before, plane weave is not the sole structure, the sole architecture for a fabric. There are several others. The second best known is called twill weave. Twill weave, it's a quite older structure, still used not that much, but still sometime you may find someone using. This was a very old way to weave for fabric. It's not as regular as the plane weave. It looks always to a solution made by 2 yarn woven in warp and 2 yarn woven in weft. That's the difference. Let's go on and see some other terms used in our business. Here we go. So the thread diameter we were saying, the thread diameter characterizes the thickness of the fabric. Normally 1.5, 1.7 times the thread diameter, that is the thickness of the fabric. And remember it, it's very important. Thickness of the fabric will be a parameter important for understanding the printing quality. Then the size of the hole that is made by the warp and the weft yarn, they leave a hole, a squared hole. That size is called open area because there is nothing. It's an open area. Well, if you consider the thickness of the fabric and the open area that is left all around, well, this as a volume, this characterizes the volume of ink that you can deposit with a print. So per each open area, you will have a deposit of ink that is equal to the size of the open area and as thick as the fabric is thick. And this is important because it's a parameter that you can calculate, and in very precise printing, just thinking to electronic printing, you can predetermine, you can predict what will be the quantity of material that you transfer from on the support thanks to screen printing. Here we go with the stretching equipment. Stretching equipment are the tools needed to tension the fabric, because in screen printing the fabric is used tensioned, stretched, and glued on a frame, on a metal frame. So there are different ways of stretching. There are mechanical stretching table and pneumatical stretching table. The best of it all is the fully pneumatic stretching system that is based on a sequence of pneumatic clamps, each one stretching, pulling the mesh for a certain size, and all working together in terms to create the most stable, the most homogeneous tension on the fabric. As you see, the different equipments have different advantages. Of course, the mechanical stretching table is the cheapest one. It's very cheap, you can find, but it's also the one that is performing less than others. It's good for low tension mesh. It's good for coarse mesh, so where the thread diameter is large enough and the thread count is small enough. While if you go on finer mesh, if you go on very precise tensioning, then my suggestion, use pneumatic clamps. These are much more expensive because you have to buy a lot in function of size of your screen. They give you flexibility and they give you a very high quality of stretching. We have not to forget the other tools that are needed in the stretching process. Stretching process, you have to measure what you do. I know that sometimes stretchers do not measure the tension they are stretching. They go in a way they are used to. So they say, okay, I'm used to go this way, and I'm pretty much sure that I reached the right point. In reality, you have always to measure because mesh might react in a different way when tensioning it. So the tension meter is an instrument that needs to be calibrated every 12 months, no way. You have to calibrate, and you have to put in strategic position over the stretched frame. If you see the design on the drawing on the right, that simulates a stretching frame. And you see 5 cross. Those are the points where we do suggest to position the tension meter to measure the tension while stretching the frame. And you have to find the same number. If you don't find the same number, then it's a problem. Then the distribution of tension is not good enough. Here we go with the stretching phases. What shall we do when we have all the equipment, the stretching table, the tension meter? First of all, we put the tension meter to 0, so we get sure that when it says 0, it measures 0 Newton. So there is no offset that is just modifying the numbers. Then I imagine that you're using clamps, pneumatic clamps, and you need to position them close to each other, not too much. Half a centimeter is enough. So keep a centimeter of space between a clamp and the next one, and position the clamps all around the perimeter of your frames. Then you position the frame and watch out that the frame has the same level of mesh. Sorry. Then put the mesh on one side and start fixing it on each clamp, and go that way in order to put each part of the mesh parallel, not not possibly blocking the clamps, but just putting the thread along a line of clamps. And then after you have closed the clamps on all the 4 sides of the frame, you can start tensioning. And there we come to the very delicate phase. tensioning is not an action that you have to do hurry up. No, you better go step by step. And the first step you put at 80% of the final tension you want to achieve. So if you want to achieve 20 Newton, you better go up with the tension to 16 Newton. And then you stop. Then you stop, you stay there for a couple of minutes, waiting that the reaction, the natural reaction inside the mesh, balance the new forces that you have applied by pulling the mesh with the clamps. After the 2 minutes, what happened? You keep tensioning, you keep pulling the mesh even more, and if you have a goal to get at 20 Newton, you better go 10% higher, so 22 Newton. And you will stretch up to 22 Newton, and once you achieve the 22 Newton, you stop for 15 minutes, leaving the mesh the time to relax. Really, the mesh has to equilibrate the pulling force of the clamps that are not distributed all in the same way across the mesh itself. And so the time is needed to have the reaction from each individual thread to be homogeneous. After 50 minutes, we can consider the mesh stabilized, and then we can glue the fabric on the frame. After gluing, it's not finished yet. Glue today is fast to dry, 5 minutes and it's dry, but you better leave 24 hours, 1 day and a half, to a further relaxation. After this further relaxation, you will probably get to the point you had, the 20 newtons that was your target. So mesh will recover, will drop the tension to the final working tension that you had established in your design. But you need 1.5 days to wait. This is something that you cannot burn in few hours. It's very delicate, and the quality of your prints will depend too much from the time you allocate for relaxation. Here, a table of max recommended tension. So many times I have been asked by customer, by friends, by technicians, by engineers, what is the maximum recommended tension? The tension depends from too many aspects, and we will see later on. But we, on our product range, the Suprex product range, we have defined on the base of our products, on the base of our experience, a range of minimum maximum tension that is recommended. Staying into that range, you can achieve good quality prints, and you can have a long life of your stretched frame. Again, what is the ideal tension? The ideal tension depends from so many aspects. We were saying before, the tension equipment. It's completely different stretching by a mechanical table or by a clamp, a pneumatic clamp. So mechanical equipment force me to stay on lower range of tension. With the clamps, I can push up to the highest level of tension in the range. The geometry of the frame has an influence on that. The frame should then resist to the higher tension. There are frames that have seen with my eyes bending after the stretching, because they were not strong enough to resist to the tension of the mesh. The quality of the mesh stabilization, yeah. The process I mentioned before, the 15 minutes, the 2 minutes first, and then the 15 minutes later to let the mesh stabilize, have an influence very much important on the final tension of the stretcher screen. Because, as we said, the stretching screen will drop its tension to a certain level. If you do not allocate enough relaxation time, the final tension will be much lower than what you expect. Then there is an aspect that you can use to correct the tension when the tension is out of your target. By using the off contact, that is the distance between the stencil and the support you are going to print, you can increase the tension applied on the mesh. So the higher the off contacts, the higher the complete tension, the final tension on the mesh during the print process. So you still can intervene, and this is one of the nice aspects of screen printing. If you know screen printing process, if you know the screen printing technology, you can always improve your product. Well, let's come now to the T-shirt printing. That is the topic of our meeting today, is how to choose the right mesh. You see here, that's the 5 mesh that are the most common in T-shirt printing. By the way, Extris is an important supplier, quite an important supplier in T-shirt printing. We are the corporate supplier for Benetton Group. So every single T-shirt made by Benetton has been printed with our mesh. But we do supply also many competitors to Benetton. So in Europe, we are probably one of the strongest, whether the strongest one in supplying screen printing mesh for T-shirt textile printing. And we accumulated a lot of experience in that field. So that's why we summarize our experience in these papers. You see, for each one of these range of products, so 43.80, what does it mean? It's 43 thread per centimeter with a yarn with a diameter of 80 microns. Well, we do suggest ideal tension to stay between 18 and 24 Newton per centimeter, which is not a bad tension. And this is a mesh that, when it's stretched at that tension, is making an ideal screen for high density ink printing, and we will see later on. You see how to choose the right mesh. How mesh count can influence printing. Yeah, we were discussing about the mesh stretched on a frame, but this is not the stencil. The stencil is mesh, frame, emulsion. And what is used the stencil for? The stencil is used to let the ink print through the holes and get on the support you want to decorate. So, a very easy rule of thumb. To get a higher resolution, then the ink deposit should be as small as possible, and the thickness of the emulsion should be as small as possible, and the mesh count should be as high as possible. This is the way to read this small table. So if you go for a 4380 mesh count, you probably will use a quite thick emulsion to print quite a lot of ink, so to have an important deposit, but with poor resolution. That's another way to read it. And let's see, for what is ideal, the 43.80 is not a bad mesh just because the resolution is lower. No, it's ideal for high opacity inks or for white inks, where I need to make a field full of ink, full of color, so I have not to print the details, but I have to print a full field. And you see that by increasing the number of thread per centimeter, so moving from 43 to 62, and using a smaller diameter thread instead of 80 micron, using a 64 micron, the mesh opening, you remember the mesh opening, decrease and become smaller. Well, through a smaller hole, I need to have a less dense ink to pass in. And so that is why this mesh is ideal for water-based inks. That is so common today, water-based ink, because customers do not want to be polluting. And if we go on with the half-tone printing, so printing fine details by increasing the mesh count and decreasing the diameter of the yarn. So in other words, getting a smaller mesh opening. Up to the 90.48, that is a mesh that can provide up to 45 dpi. That is not a bad resolution. Still not the finest that we can achieve, but not bad for a t-shirt. Finally, we get at 120-34. This is a very fine mesh. From there, we start with the fine mesh family, and these are mesh, the 120, the 140, the 150, ideal for color processes. So where I can print any kind of color by just overlapping different colors among the four basic colors. So we mentioned stretching the screen, we mentioned the emulsion, we mentioned the inks, but a stencil, that is the tool needed for printing. What makes a screen to become a stencil? Very easy to say. To prepare a stencil, once I have the stretch screen, I have to coat with emulsion or apply a film, a capillary film. When should I coat with emulsion? When should I add a capillary film? A different solution. Emulsion, it's coating with emulsion means to have a non-regular thickness over the mesh. A layer of emulsion that is not exactly as thick in each point. The film application, it's different because with film, I get a stencil with a very plain surface with very proper thickness, very precise thickness. What is used for a film-coated stretcher screen? Well, this is ideal for thin printing like electronic printing, while an emulsion-coated stretcher screen is ideal, for example, for T-shirt printing. T-shirt printing, I can use emulsion with solid content, with important solid content, so emulsion that can become very thick, and in this way I can print very thick parts of inks. So let's get to the color of mesh. You probably noticed that mesh usually in screen printing are white or yellow. Some very fancy weavers still offer orange color mesh, but this is going to disappear. The main two colors are white or yellow. And normally white is the color used up to 90, 100 thread per centimeter. And from 100 thread per centimeter and up, the preferred color become yellow. Just because of resolution. With the yellow color, we can increase the quality of the edge of the decoration we're going to print. So it's what we call printing with sharp edge, because a yellow mesh has a lower ability to transmit the light during exposure, and so has a better good for better resolution details. While the white mesh some way reflect the light. So when we go to the exposure of the emulsion, then we have reflection that's not all useful. There are even spurious reflection that may influence the resolution. But with coarse mesh, there is not a problem of resolution. So again, summary, white mesh up to 100 thread per centimeter, yellow mesh from 100 thread per centimeter up to 165. Here we are with Andrea that is going to show us how to stretch a frame. Let's see.
Hello everybody from Extris. My name is Andrea and I'm here today in order to show you how to stretch a screen printing frame properly. So first of all, before to start, we have to be sure to have in our house this very important instrument, which is a tension meter, a mechanical tension meter, which allow us to measure the tension on the screen. After that, we have to make an easy calculation basing on our final tension. Why? Because we have to reach our final tension in 2 steps in order to allow the polyester yarn to relax. So we have to make an easy calculation of 80% of our final tension. For example, let's suppose that our final tension is 20 Newton, the 80% is about 60 Newton. Stretch in the first step in order to reach 60 Newton. And the second calculation is to get the 15% more of our final tension. It means that if we are basing on 20 Newton, the 10 or 15% more than our final tension should be about 22 or 24 Newton. After that, we can start to stretching. So I have prepared the equipment previously, and now I can start to stretch our mesh. So we give the air, we give the tensioning, and in a few seconds you will see that our mesh will start to stretch on our facility. In the meantime, my suggestion, especially in the break between the first and the second step, the tensioning, my suggestion is to start to prepare our glue that allow us to fix our mesh on the frame. Okay, as you can see, the clamps will start to stretching our frame. It means that now we can start to measure our tension meter. Our tension meter, it must be placed in the middle of the screen, and the indication help us to stop as soon as we will reach the first step tensioning. As we decided before, is about 60 Newton. So we are still at 20 Newton. Let's give a little more tension. Okay, here we are. After that, let the mesh relaxing for a while, 10 minutes, and in the meantime, we can go to prepare our glue. Okay, guys, here we are after 10 minutes. Now we have reached the tension of about 60 Newton, okay, as per indication of our instrument. And after that, we can start to give the second step stretching in order to reach a tension of 22 or 24 Newton. We stretch more than our final tension because after between 24 and 48 hours, the polyester relax a little bit. So the risk is to lose too much tension. So my recommendation is always to stretch a little bit more higher in order to allow the polyester to don't go lower than 20 Newton, which is our final tension. Okay, once we have reached the tension of 24 Newton, we can start to doing. Thank you very much for all, and have a nice screen printing.
Thank you, guys. Thank you for your attention. I hope that you have seen something interesting today for you. For any question, please, for any further question, please, you can contact us by email. We will be more than happy to be of help to explain you in details. Thank you again. Have a nice day. Bye.